Hello everyone. We are the students of Vishwakarma Institute of Technology Pune from first year Division H Group 3. And in this video, we will be explaining about division restoring algorithm. These are our group members and this is the table of content we are going to explain in this video. And now we will start with history and basic of division restoring algorithm. The division restoring algorithm is a long division algorithm used to divide integers or polynomials. It was first proposed by St. Goodwill in 1951 as a modification of the well-known restoring division algorithm. The restoring division algorithm was originally developed by C. Babbage in the early 19th century for use in his analytical engine, which was one of the earliest mechanical computers. The division restoring algorithm works by repeatedly restoring the dividend after each subtraction instead of always subtracting the divisor from the dividend. So the basic idea behind the algorithm is to align the divisor and dividend and then repeatedly subtract the divisor from the dividend until the remainder is less than the divisor. At each step, the quotient and remainder are calculated and the dividend is restored by adding the divisor to the remainder. The algorithm continues until the remainder is 0 or the desired number of quotient digits have been obtained. Basically, the division restoring algorithm has several advantages over other division algorithms. It is faster than some other algorithms, such as restoring division algorithm, and it is easier to implement in hardware because it only requires simple arithmetic operations such as addition and subtraction. However, it has higher hardware complexity compared to some other algorithms. In summary, the division restoring algorithm is a fast and efficient long division algorithm that is commonly used in computer systems for high speed division operations. Its advantages and disadvantages makes it a popular choice for different applications, and its history dates back to the early days of computing.
So let's start with types of division algorithm. There are two types of division algorithm. First is slow division algorithm and second is fast division algorithm. So let's see slow division algorithm. Write the dividend and divisor in long division format. Divide the first digit of the dividend by the divisor and write the result. Multiply the quotient by the divisor and write the product under the first digit of the dividend. Subtract the product from the first digit of the dividend to get the remainder. Bring down the next digit of the dividend and repeat step 3 and 5 until there are no more digits in the dividend. Next is a fast division algorithm. Divide the divisor by 2, 4, 8 and 16 until you get a number less than or equal to the dividend. Write down the powers of 2 that you used in step 2. Multiply the divisor by the power of 2. Subtract the result from the dividend to get the remainder and repeat steps 2 and 5 with the remainder until there is no remainder left. Add up all the powers of 2 you wrote down in step 3 to get the question.
I am Tanaya Zada. Today I will be explaining the flowchart of division restoring algorithm. This flowchart consists of 4 to 5 main steps. If you know the steps beforehand, the further calculations will be easier. Now let us look at each of the steps one by one. First is initialization. Here we have to initialize 4 values n, a, m and q, where n is the number of bits in dividend, a is the accumulator, m is the divisor and q is the dividend. The value of a and m, that is the number of bits, will keep on changing as we have to use the formula n plus 1, which is dependent on n. Let's take an example. Say 11 divided by 3. Here, the binary representation of 11 is 1011. Therefore, it is 4 bits. That is why n is set to 4 and q is set to 1011. Here, the accumulator is initialized with 5 zeros according to the formula n plus 1. Similarly, the binary representation of 3 is 1 1, and as we want 5 bits, 3 zeros are added to the left of it. Moving on to the second step, it is shift left operation. In this, the MSB is discarded and each bit is shifted to left by 1. Here we can see an example 0 0 1 1 1. The leftmost 0 is discarded and the rest of the bits are shifted to the left. You can see the LSB is empty, which can be filled in for the process. Next is the step 3, subtraction. It is a simple binary subtraction wherein you have 4 cases for 2 inputs, that is 2 raised to n, and you can refer this table for the subtraction. Fourth step is the checking the MSB of accumulator, and based on these steps, the further steps will be performed at some point in the given flowchart. If the MSB is equal to 1, then the accumulator will be restored, and Q, which is the divisor, its LSB will be set to 0, and this is denoted by Q of 0. If the MSB of accumulator is 0, then Q of 0 is set to 1. Now let us look at the flowchart. In this process, initialization takes place, then shift left operation is performed on accumulator and Q, which will be shown in the example further. Then subtraction is performed, after which the result is stored in accumulator. The MSB is checked, and according to the values, either 0 or 1, the corresponding steps are executed. Then n is decremented by 1. If it is equal to 0, then you get the quotient and remainder, which are stored in register Q and A accordingly, and the process is terminated. If n is not equal to 0, then you have to return back to the shift operation and perform the following steps until the required condition is satisfied. That is all for the flowchart of this algorithm.
Now let's look at an example for better understanding. In this problem, the dividend is 11 and divisor is 3. First, we have to convert 11 and 3 into binary numbers. The binary conversion of 11 is 1011 and 3 is 0011. Next, we will declare m as a divisor and q as a dividend and set a equals to 0. Now let's calculate minus m. 2's complement of m will be minus m. Therefore, we will add 1 to 1's complement. Therefore, our value of minus 1 is 11101. Now let's implement the algorithm. First, we have initialized the value of variables. The next step is to shift left a key. Here we will shift one bit at a time toward the left side. Hence, vacancy is created at the LSB of Q. Next, we will perform the operation A equals to A minus M. If the rightmost bit of A after the operation is 1, then we will set Q0 equals to 0 and restore the initial value of A. If the rightmost bit of A is equal to 0, then we will set Q0 equals to 1 and continue with the value of A. After this, we will decrement the loop, and now our value of M will be 3. In a similar manner, we are going to perform the operation until the value of n becomes 0. When the value of n becomes 0, a is our remainder and q is our quotient. Therefore, after converting a and q to decimal, the value of remainder is 2 and quotient is 3. We all know that dividend equals to divisor into quotient plus remainder. After calculating this value, we are getting 11 as a dividend. By using this formula, we can cross-check our answer.
My name is Ayush Jakkar, and I am here to give you describe about difference between restoring and non-restoring algorithms. The main difference between restoring and non-restoring algorithm is the way they handle the negative integers. For the restoring algorithms, negative reminders require additional restoring step to adjust the reminder, whereas non-restoring algorithms they don't require no additional restoring steps. In general, restoring algorithms are slower as compared to non-restoring algorithms, and restoring algorithms requires no hardware to perform non-restoring algorithms, whereas to perform restoring algorithms by non-restoring requires specific hardware. Second is the application of using division restoring algorithms. Now, there are many applications while using the division restoring algorithms, but here are a few main use of division restoring algorithms. Here are as follows: division operations, computer arithmetic, floating point division, and digital signal processing, or in short, DSP. The division operations. The primary purpose of division restoring algorithm is to perform division operations. It allows for division of large numbers or binary values with high precision and accuracy. Second is the computer arithmetic. PRA is a commonly used in computer arithmetics, where division operations are an essential part of mathematical calculations. It helps in performing division efficiency in a hardware or software implementation. Third is the floating point division. It can be utilized in floating point division operation
which are essential in scientific and engineering applications. It enables the division of floating point numbers with high precision and accuracy. Second, and the last one is DSP. The application often require division operation for tasks such as filtering, modulation, and demodulation. Division restoring algorithms can be employed to perform division efficiently in DSP algorithms. That's it from my side.
My name is Sonia Jadhav and today I'll be explaining the advantages of division restoring algorithm. The first one is parallelism friendly. Division restoring algorithm lend themselves well to parallel implementation in both hardware and software. The second one is simplicity. Division restoring algorithms are relatively simple to understand and incomplete to compare to other division methods. The third one is no iterative process. This attribute make them more efficient for time critical application where minimizing the number of iteration or clock cycle is crucial. Suitable for hardware implementation. Their simplicity allows for efficient hardware design, reduce gate count and minimize power consumption. Next I'll be explaining is disadvantages of division restoring algorithm. The first one is the slower than other algorithms because they involve multiple steps and require multiple interaction to compute the quotas and remind that it is slower than other algorithms. The next one is efficiency for large operands. Division restoring algorithm can become increasingly inefficient as the size of the operands grows. This is particularly true for hardware implementation, where the number of bits in operands affects the complexity and resources required. The last one is lack of support for fractional division. Division restoring algorithms are primarily designed for integral division operations, hence it has a lack of support for fractional divisions.
Thank you all for your time. And if you have any questions, please do ask them in the comment section and like the video. Thank you.